Hey everyone, just going through a Desmos demonstration on shading and using inequalities. So this is part of a art project, likely that you're trying to do, or some other project where you need to shade in between some sort of lines or curves. And we'll just go through a few options that you have for doing that. So right now I've kind of put up a few sample curves, couple parabolas, a circle. There's one line here that's duplicated. There's a reason for that we'll get to later, but there's a purple line and then a black line right on top of that. And all these lines have been restricted except for the circle. So the circle, you can see the whole thing. But we will go ahead and talk about just trying to shade in, say, inside this area right here. Maybe shading inside the circle or this area without the circle, those sorts of things. So the first off, the easiest thing to do if you're shading between two different curves is just to say your y, if these are defined as y in terms of x, that your y has to be in between those two things. So you could say I see my red curve here is on the bottom, my blue curve here is on the top, and I've called those y1 and y2. I'm just going to say y1 needs to be less than or equal to y. So I'll shade everything above the y1 and then less than or equal to y2. So you can do kind of these compound inequalities where you have a lower end and an upper end. Now notice a couple things. This is that these curves, it went ahead and kind of restricted itself to just a few of these pieces. So you'll notice on the left side, this red curve kind of ends right here at -1, but the blue curve keeps going, and likewise at the top, the blue curve kind of ends over here at 2, but the red curve keeps going. It's only going to shade in between parts where your equation for both the top and the bottom are met. So it's not going to shade anything to the left of this point here or this line at x is -1 because your blue curve is defined but your red is not. So since your red is not, it doesn't know what to do over here on this side. Also over here, right, my red is defined but my blue is not, so it doesn't know what to do over here. So that's all it's going to shade in between those two parabolas as they are defined right here with those restrictions. Now, you can undo some of those restrictions if you want. So if I said, well, this red curve, maybe it's okay over here, but I'd really like to shade all the way up to that blue curve over here and then just cover it up with this circle. There's a couple things you can do. You can copy and paste, right? So that red curve was this x squared minus 5. So I can just copy that, replace that y1 at the bottom with the actual definition, right? So just copy and paste it in there. And now it's going to shade all the way up till I get to here, where we actually get an intersection between the two. And then if you kept going, the red would be above the blue, so it can't shade after that. So that's one thing you can do is just replace, right, any of these y1, y2s that are restricted with the actual function curve, and then you can create new restrictions or just ignore any restrictions that you had created previously and either don't have any or just put in new ones. That's right there on the inequality. For circles and other things like that, so I'm going to go ahead and replace this back with my y1 for now. Circles, if you want to shade those, that is usually just a matter of copying and pasting some stuff. So I'm going to copy this circle, paste it down here, and instead of an equals, I'm going to use a less than or equals. So that will give me that line right there with it all shaded in. Now, depending on what you have in your order, right, will kind of depend on what's on top. So later things are going to be put on top. So if I want that green to still show around the edge, then I would just need that shading to be up above that green equation. So the green down below is going to just be placed on top of the purple. And so we'll still get to see anytime you want shading where the border is a different color than the shaded piece. That's kind of how you do it. You just do two pieces, one with a line, one with the shade, and just make sure your shading is underneath by putting that equation somewhere in the list above the line. So that's kind of how that will go. Now, if you wanted to shade, let's say, outside the circle, you just have to change your inequality direction. So that would be now greater than or equal would shade outside that circle, and everything gets shaded that's out there. Now you can put in more restrictions, right? So you can still put in, say, like this y1 less than or equal to y2, that sort of thing. So we could put in y1 less than or equal to y, right? And that'll still shade everything outside the circle that's there. Or if I wanted to say, let's do the other one, where I take y is less than or equal to y2, right? That'll also shade everything outside the circle. So you notice we're shading basically everything under that blue parabola. But when we get to the circle, we kind of have that hole, right? Because we want to shade everything outside the circle. And you can put in as many restrictions on here as you want, right? So if I go ahead and close that off, and then maybe I'll start a new one that says y is, or y1 is less than or equal to y2. Then I'll also shade that piece as well. So you can throw in kind of as many pieces as you want to these guys. That should be just a y, not y2. So there's that piece. Again, it's going to follow, right, any sort of domain restrictions on these guys. So if your y1 starts here, and then your y2 kind of ends here, it's going to have to meet both conditions for it to be able to shade. So sometimes if you want to get like this entire piece in here without the circle, you might have to get a little creative. So we'll try a little bit of that here in a second. So I'm going to go ahead and let's just eliminate this piece right here and talk about what we had right here. All right. So going through on this piece, we have kind of a nice curve around here, but I'd really like it to not go all the way past that red parabola. So what I'm going to do is just say maybe we'll restrict this ourselves a little bit more, and then just create more than one piece to shade this area in. So we may not be able to get it all in one shot, but we can certainly do it with more than one piece. So right now the y2 is the top edge, that blue parabola. I'd like to just continue that at least right here till I get to that -4. So I'm going to kind of shade the bottom as -4 less than or equal to that y. So now it's going down there, coming all the way down to -4, then kind of stopping. We did kind of overlap this red one again, so I'd rather not have that. So maybe we'll go ahead and also restrict my x to right here around -1. Right, so we're going to also say, throw in another inequality, that x needs to be less than that value of 1. I think I might have said -1, but I meant 1. So there's that value of 1 right there, and we're just shading everything with the x less than that. So you can combine y restrictions, you can combine x restrictions, you can combine lines, right? If I wanted a y is mx plus b line going straight through the middle, I could do that as well. So all those are different types of restrictions you can put in. So for instance, if I wanted, instead of a circle that looked like that, just like a y is less than or equal to, we'll say x minus 6. And actually I need a -x minus 6. Then that would be this part right here, where that line y equals -x minus 6 is kind of cutting off that circle, right? We want all the y's below it. So even in your lines, you can use the restrictions to sort of cut off things at an angle. It doesn't have to be kind of a straight shot on those. All right, let's go ahead and keep going with these guys. So I'm trying to get in here. What might be best is to go ahead and shade right in between this blue and this red, just on this area from 1 to 2, and then between the black and the red from this area between there. So because this circle created kind of some havoc with this left side, and because my blue is no longer defined right past here, and I don't want to go past it over here, we're going to have to get a little bit creative with some of our shading. All right, so let's go ahead and say we'll put in 2 more things. So let's just do the regular one where we said the same deal. All right, and actually, let's do this. I think I have it down here, this part right here. The y1 less than or equal to y less than or equal to y2. Right, that'll get all of this part, including down here, between the red and the blue line. And then we just need this tiny piece over here. So I'm going to go ahead and say I need to be between that black and that red. The problem right now is that this black or this purple line, right, is kind of defined in terms of x. Right? I don't have a y, I have an x equals. So I have a y equals equation. So this can sometimes also be something that happens. We'll go ahead and work our way around it. So one way is just to rearrange the equation. Right? This equation you could rearrange. You get a y for your top, and then do the same thing as this, like y1 less than or equal to y less than or equal to, and you could call that like y3 or something that went right there. The other thing is you can just put in more pieces, right? So I could say I need my x less than or equal to that x1. All right, so I'll shade to the left, and I don't need to go all the way over. I can kind of cut it off anywhere here, really before I get to 0, probably. So we'll say also on the lower bound, 0 is less than or equal to that x. Or you could even use 1, just something inside, right, inside this region. So I don't go too far past that edge. And then this last piece right here, we'll just throw in 1 more. So we'll say y is greater than, or actually let's say less than or equal to my top bound, which will be somewhere around, we'll leave that blank for a minute. Let's put in our lower bound. So again, I'm going above y1. So now I'm shading everything above this parabola that's on the bottom. But I do want to kind of cut it off right here. So you can hover over that point. See, that's around 2.5. So for my x, 1.25 for my y. So we want less than or equal to 1.25, right? And that would kind of cut that off right there. So I've used now kind of 4 inequalities to define that region. It's not maybe ideal, but sometimes it's just what you have to do. So if you can't rearrange some of your equations, maybe they're a lot more complicated than just a line, then you can always shade left to right, shade up and down on different parts, and just combine them all together in the end. If we go ahead and make all these the same color, right, usually that's kind of what you're wanting to do if you're shading the same region, is have the same color. So let's go and make all of these. Let's do orange. For some reason, Desmos rarely picks orange. All right, so all of these, that was one of my lines. I'll put that back on green. All right, we're missing this one. It needs to be orange. All right, so they're all shaded orange. Now you'll notice that with all of these kind of restrictions and overlaps, that some pieces are lighter orange, some pieces are darker orange where there's more overlap. If that's not what you want, then you need to adjust the fill. So the fill on here, if you set it equal to 1, we'll basically shade that a solid color. So it won't be opaque and see-through like it was before. So you just need to go change all of those to a fill value of 1. Sometimes they refer to this as opacity, and then it'll all be shaded that orange color that's right there. If you don't want your border lines to be quite as thick, you can also change that. So that can be also change those to 1. Sometimes that helps your lines that are on top stand out more once you put them on top. And then, like I said, if I want any of these equations to kind of be above that shaded region, then I'll go ahead and put those lower down. Put all my shading up at the top, put all my other equations lower down. That way I can see the border for those guys. If you want thicker lines, you can also change these. Maybe I'll change this to a 4, make that thicker line. Right, that one a thicker line, that one a thicker line for all of those guys, and the red also thicker line right there. So you can adjust some of those parameters as you're going through. That is kind of the basics of going through and shading. One other thing I'll mention real quick with the conic sections like a circle or hyperbolas, ellipses. So let's say this is an ellipse. You can still shade with that. So you can say this is less than or equal to 3, right? And it'll shade in between, or greater than or equal to 3, right? It'll shade one side or the other. Again, you would probably add in some restrictions like y is bigger than whatever this value is here, like -3 maybe. If you just want the top, throw in another restriction where maybe there's a line cutting through it that you want to stay below. So you can always throw in extra restriction lines right above this. So I'll go ahead and just put in a couple. So let's say we want y bigger than x, right? Actually, let's say y less than or equal to x plus 5, right? So that would be this top line right here that's getting covered, and maybe we want also a lower bound where I don't include the bottom half of the hyperbola. Maybe we'll just throw in like a -3, something like that. So -3 somewhere down here, that number's not super important. We just don't want it to get below the other half. So there's the top half, and then maybe there would be another restriction, right? You can throw in more than one where maybe y is less than or equal to, let's make this one a -x, right, plus 2, something like that. So you can throw in as many of these sort of restrictive curly braces as you want that define your edges of your shaded region. Usually one equation will be defining your shading, and then you can have a bunch of other restrictions that kind of put borders around all of these guys. So that's one way of going through and just making sure that all your pieces get shaded. I may come back and do another video with a few other tips, but that is the main gist of shading in Desmos. Just kidding, there's one tip I forgot. So last thing I wanted to talk about, I'm going to go ahead and hide that piece, or actually we'll just change that back to an equals and take out those restrictions. Change that back, make our circle. So one thing I did forget is kind of the definition with this x1 and this x that's right here. So when you're dealing with these guys, it's fine. I hide that black one to say something like x is less than or equal to that x1, right? So this is an x function defined in terms of y. I've got y restrictions there. So it'll work this kind of the same as with the y's as with the x's, just reversed, right? So if I wanted that also greater than or equal to some number, right, I can cut it off. What gets tricky is that when you are working with maybe an equation that you did x in terms of y, but then you used x restrictions. So this black line has x restrictions. Then some weird things happen. So for one, if I try to call this x2, you'll notice the line disappears. So Desmos doesn't really like this being called x2 in terms of y when I have x restrictions in this curly braces. So that's one weird thing that will sometimes happen. If you have an x equals stuff in terms of y, but then x is inside those restrictive curly braces. The other thing that can happen is if I went ahead and tried to do an inequality, right? So maybe I just said, I'm going to try it anyway. X is less than or equal to this. Now it's, for some reason, right, looks like it's shading in the y direction, not in the x direction like it did before when I went way out with this guy. So remember this one, when I said x is less than or equal, take off the x one for now. Then it went to the left, right? All the x's lefts. This time it's going down, which looks really weird. Might seem strange because I still have the same kind of definition there. If we throw in the equal for the less than or equal sign. What's happening is it's rearranging this kind of in the background to say, well, your domain restrictions are in terms of x, so you must have really wanted a function of y instead of a function of x in terms of y. So you must have wanted y equals something in terms of x or less than or equal to something in terms of x instead of x in terms of y. So it's using this restriction right here to kind of define what else it's going to do over here with the original definition. So that's just one other thing to be aware of, which that might have been okay, right, if we had said, oh, that is kind of what I want to do, shade below that line. But then it's hard to say also shade above y at that case, because then it's kind of weird. I'm not defined in terms of y yet. So it's hard to combine these inequalities when I have x in terms of y, but then my restrictions are in terms of x. So generally, what I would say when you're going through these guys and defining functions, if you have a y equals, make sure if it's in terms of x, your restrictions are also in terms of x. And if you have an x in terms of y, your restrictions are also in terms of y. Usually it just makes things a bit easier. Okay, I think that'll do it for now. Like I said, if I think of some other tips, I'll come back in and record a separate video.